Welcome to the today's lecture on Playfair cipher. This is a diagram of substitution cipher, which means it encrypts the pairs of letters instead of single letters. This was invented by Charles Wheatstone in the year 1854. It was popularized by Lord Playfair, hence its name. This cipher provides more security than simple substitution ciphers by using a 5x5 grid of letters as its key. And this application commonly used in military applications due to complexity and letter pair encryption. The core of the play cipher is a 5x5 key square which contains the letters of the alphabet arranged based on a keyboard. Letters are paired up in the plain text and each pair is encrypted according to specific rules applied to their positions in the grid. We will see these rules next, which depend on whether the letters are in the same row, the same column, or neither. These are the matrix rules for Playfair cipher. The encryption rules for Playfair cipher is as follows. If both letters are in the same row, each letter is replaced by the letter to its right, wrapping around to the start if necessary. If both the letters are in the same column, each letter is replaced by the one directly below it, wrapping around if needed. If the letters form a rectangle, they are swapped with the letters in the same row but the rectangle's opposite corners. These rules effectively mix up with the letters, making it harder to crack by frequency analysis alone. One of the example of the Playfair cipher is we are taking the keyword monarchy. Each letter in the keyword is placed in the grid first. Without repeats, followed by the remaining letters of the alphabet, the letter J is usually omitted or combined with the letter I to fit the 5x5 grid. In this example, the key square is arranged with M in the first cell, followed by O, N, etc. So, this is called multiple letter substitution cipher or diagram cipher, where we are encrypted and decrypted. We are taking the plain text when we are encrypted the plain text, we are getting the cipher text. Let us take the keyword monarchy and the plain text we are taking here HSEAARMU. So this is a 5x5 grid. Our keyword monarchy is fixed here in the 5x5 grid. Then we are followed, except these letters of the alphabet, we are following the remaining letters in the 5x5 grid. So these are the outline for the algorithm. We can generate a key matrix from the keyboard. Then we can prepare the text, a pair of letters we are adding here, and add filler for repeated or single letters. We can encrypt and decrypt by using the matrix rules. This is our C program structure. First, we will initialize the variables. At the time of initialization, we will initialize the key matrix, plain text, and ciphertext. We can generate a key matrix where we can input the keyword. In our example, we are taking the keyword monarchy, then fill 5x5 matrix omitting these repeated letters. Then in the next preparation, we can input the plain text, add filler characters if we require. Then we will apply the encryption function by applying the Playfair rules. Then we will apply the decryption function, which is nothing but the reverse of the encryption rules. These are the advantages and disadvantages of Playfair cipher. Let's look at the advantages of Playfair cipher. Advantages include its ability to encrypt digraphs, making it more secure than mono-alphabetic ciphers, and ease of use as it doesn't require complex mathematics. However, it's still relatively weak by modern standards as frequency analysis of digraphs can still reveal patterns. Also, it's less secure than polyalphabetic ciphers like the Vezinier cipher. Despite its limitation, the Playfair cipher remains a historically important method in cryptography. these are some of the disadvantages. The key size is very limited here. The poor performance where we are applying with the large text and non-alphabetic characters while handling, we are getting very weakness against known plain text attacks, and the matrix limitation is very less. So this is about the layout, which provides a comprehensive layout by representing the Playfair cipher program with C code. Hope we will understand both theory and implementation. Let us discuss about the implementation part of Playfair cipher. This is our program where we are implementing the Playfair cipher. So first we will include the header files here. This library is included for input and output functions such as printf and scanf, stdio.h, then string.h, which is used for the string manipulation functions. Then we are using the ctype.h, which is included for character handling functions such as converting characters to uppercase. Then we are defining the size of the Playfair matrix. The size, we are taking the matrix size 5 by 5 here. So we are defining the size of a matrix 5 by 5. Then we are creating a matrix here. To create a matrix of the Playfair cipher, we are defining one macro here, which is the size of a macro. Here we are defined 5 by 5 size. This is represent the 5 by 5 Playfair matrix. Then we are using one particular function to create the Playfair matrix here. So we are mapped the alphabets 0 to 25, totally 26 here we are mapped, and we are using some of the parameters we are adding in these functions to take a string key as a input, and we are mapping 26 here, and integer NA initialized to 0 to keep track of which letters have been added to the matrix. Then here we are filling the matrix. This function iterates through each character of the key. Each character is converted to uppercase here. If the character J is J, it is treated as I here. If the character has not been added yet, it is added to the matrix and the corresponding index in the map is updated here. The matrix is filled row wise. When a row is filled, it moves to the next row. Then here we are filling the remaining letters. After filling the matrix with the keyword, the program fills the remaining alphabets A to Z, skipping J. This process is similar. It checks the letters has been added to the matrix and fills it accordingly. Then we are using how to display the Playfair matrix. This function prints the Playfair matrix to the console here. It uses nested loops to traverse through the matrix and prints each character. Then this is the function to find the row and column of a character in the matrix, where we are taking the loop I and j, which will be rotated to the size 5 by 5. So each matrix when we are taking the row and column size, it can be printed character by character in this one. So this is the function which is used to prepare the plain text by dividing it into group diagrams. Then this is the function to encrypt the using Playfair cipher, where we are taking the letters to move down, move right, according to the rules of the Playfair matrix. So what are the rules we are represented here? The rules we are represented here is if both the letters are in the same row. So if both the letters are in the same row, Then each letter is replaced by the letter to its right, wrapping around to the start if necessary. If both the letters are in the same column, this is the same column, each letter is replaced by the one directly below it, wrapping around if needed. Then if the letter forms a rectangle, then they are swapped with the letters in the same row but at the rectangle's opposite corners. These rules we are applied to move right, down and swap the columns. Then this is the function to decrypt using a Playfair cipher, the same which is the reverse of the encryption we are taking to move up, move left, move right and swap columns. Then at last we will use to display the main function here. The main function initializes a keyword Playfair cipher here. First we will take to enter the key. So it calls the create matrix key to generate the matrix based on the keyboard here. Then it will call the create matrix, which represents the matrix based on the keyboard. Then it can cause the display matrix to print the resulting of 5 by 5 Playfair matrix. Then it can accept the plain text. For example, we are taking the plain text as hello or hello world. Then after accepting the plain text, it will call for encryption. After encryption, we are getting the cipher text. Then after decryption, we are getting the same plain text. So with this, we are concluded our program. Then let's run the program this one. So here we are taking the key. Let us take the Then this is our Playfair matrix, which is MONARCHY. Except these we are excluded. The remaining characters here we are printed. And I, if we have placed I, J is omitted here. Let us take the plain text here, HELLOWORLD world. Then this is our prepared text. Then this is our encrypted text, and this is our decrypted text. So like this, our Playfair cipher works according to the Playfair matrix rules. So this program effectively demonstrates how to create and display a Playfair matrix, how to encrypt the data, how to encrypt the text, and how to decrypt the plain text. This handling of duplicate letters of the execution of J are crucial aspects that enhance the cipher security. With this, we are concluded our session. Thank you.